This lesson is about similar figures. The essential question states, what are corresponding sides and how can I use them to find missing side lengths? First of all, we need to discuss corresponding sides. Corresponding sides are sides in a shape that are in the same position but in different figures. So here's an example. We have triangle ABC on the top and triangle PQR on the bottom. The corresponding sides are shown in different colors. So for example, this side right here that's blue is corresponding to the side in triangle PQR that is also blue. The side that's green, side AB, corresponds to side PQ, and the side that's red, BC, corresponds to the side that's red here, which is QR. So they're in the same position, the left, the right, or the bottom, in each figure. Similar figures are two figures that are similar because the corresponding parts are proportional. Okay, so they're not going to be the same size necessarily, but they will be the same shape. So on the left, you can see some examples of similar figures. A small equilateral triangle and a large equilateral triangle. Okay, another example would be a large trapezoid here and a small trapezoid here. Okay, they're the exact same shape, not the same size, and if there were numbers here, we would see that they are proportional. On the right side here, we can see some figures that are not similar. On top, we have an equilateral triangle and a right triangle. Okay, even if the numbers showed proportions, they would not be similar because they're not the same type of triangle. The trapezoids on the bottom are not similar. Just because they're trapezoids, they do not have proportional lengths. As you can see, the top of the big one is not the same proportional width to the one on the right. Okay, so one thing that you will need to do is determine if something is similar to another shape. So we have a big triangle on the left and a smaller triangle on the right. So we are going to compare each side in each figure. Okay, so here's a chart that shows the side lengths. The big triangle ones here, 20, 8, and 16, and the small triangle lengths here. Okay, the 20 on the bottom corresponds to 15 on the bottom of the smaller one. The 16 corresponds to the 12, and the 8 that's on the left corresponds to the 6 that's on the right. So we're going to compare each part and make a fraction. So 20 over 15 simplifies to 4/3. Okay, 8/6, which are the corresponding sides, also simplifies to 4/3. And then the last pair of corresponding sides, 16 and 12, also simplifies to 4/3. Because they all simplify to 4/3, that makes these two triangles similar. Here's another example. So we have a right triangle here that's 6 by 10 and a smaller right triangle here that's 3 by 5. Okay, again, you're going to set up fractions and simplify them to see if they give you the same number. If you get the same number, they're similar. If you get different numbers, they are not similar. So the height of the big one, 6, compares to the height of the smaller one, which is 3. So 6 over 3 simplifies to 2 if you divide. And then the lengths are corresponding, so 10 over 5 also simplifies to 2. Because we got 2 for both fractions, that means they are similar figures. Another thing you'll have to be able to do is solve for a missing side. Since similar figures are proportional, we can set up equal fractions to solve these. Take a look at this example. We have a 9 by 6 rectangle and another rectangle that's x by 14. We are trying to figure out what the x is, and we're going to do this by making a proportion. There's a couple of different ways you can set this up, and as long as you have the corresponding sides in the same place, then you'll know that you're on the right track. So I did the length of 6 over the length of 14. in one fraction, and then the width of 9 over the width of x for the other. Okay, so in this example, I have the small rectangle dimensions on the top and the big rectangle dimensions on the bottom, but I also have the lengths in the first fraction and the widths in the second one. So that's just one way to set it up. There's a couple other ways you can also set it up, but make sure your corresponding parts match. So now we're going to cross multiply. 14 times 9, and then we're going to divide by 6. So that would give us 21. So that means x equals 21 centimeters. Here's another example. We are going to solve for G. I think that's this right here. So these triangles don't look similar, but imagine if this bigger one were flipped around. So the corresponding sides would be 4 and 5. So that I have that in the first fraction. And then the other corresponding sides now that I look at this, I don't think this example is correct. So we're going to go ahead and skip this one. Sorry about that, guys. All right, so take a look at your additional example sheet. So number 1, it says determine if the following figures are similar. So we can see some measurements here, 18 by 36, and then the other rectangle is 25 by 45. So there's two ways we could set this up. We could compare the widths, 18 and 25 in one fraction, and 36 and 45 in the other. And by looking across the top, we would see 18 goes into 36 twice, but 25 does not go into 45 twice. So that leads me to say that they are not similar. The other way you could set this up is use the length and the width in one rectangle compared to the length and the width in the other. So that would look like 18 over 36 and then 25 over 45. Now we're comparing up vertically. So 18 goes into 36 twice, but 25 does not go into 45 twice equally. So again, that leads me to say that they are not similar. Number 2 says find the missing sides. In this example, we have 3 missing sides, x, y, and z. So we're going to have to set up 3 separate proportions to figure this out. So I'm going to start with x over 5 and then 10 over 4. It's very important that I have the x on the top and the 10 on the top because they both come from the same shape. Now we're going to cross multiply. 5 times 10 is 50, and then I'm going to divide by 4, so x would be 12.5. Now for y, I could use what I figured out for x, but I'm going to keep using the sides that I was given, which were 4 and 10, to compare y with 8. So I'm going to start with y over 8, and because I have y on the top, that means I have to have 4 on the top for my other fraction. I can't use 15 or 5 because I don't know the corresponding sides of x or z. So now we're going to cross multiply. 8 times 4 is 32, and then divide by 10, which is 3.2. So y is 3.2. And then to figure out z, z corresponds to 15. So I have z over 15, and then 4 over 10. Again, cross multiply. 15 times 4 is 60, and then dividing that by 10 would give you 6. So z equals 6. The last additional example says, a 6-foot-tall man casts a shadow that's 4 feet long. If a dog casts a shadow that is 1.5 feet long, how tall is the dog? So I encourage you to draw yourself a picture for this, and it basically makes a right triangle. So the one on the left here shows the 6-foot-tall man standing up, and then the shadow on the ground is 4 feet long. And then I'm going to draw a smaller triangle for the dog. So we don't know how tall the dog is, so I put X there, but we do know his shadow is 1.5 feet long. So now I can set up a proportion. So X corresponds to 6, and 1.5 corresponds to 4. You could also have 6 and 4 corresponding, and then X and 1.5 corresponding. That would be fine as well. So I have it set up right here, and now I'm going to cross multiply. 6 times 1.5 is 9, and then I'm going to divide by 4, So that gives me 2.25. So that means the dog is 2.25 feet tall.